Today we're going to talk about the linear function. Still, this is just the second part. So as we go and look right here, let's review from yesterday. It says to draw the linear parent function. Well, first off, what is the equation for the linear parent function? This is something you have to have memorized. The linear parent function is y equals x. You need to have that written down. You have to have that memorized. Now, I should have already gotten my calculator out, but let's do that now. Make sure you have yours. Y equals x. Oh, it went crazy again. Try again. There we go. Go to y equals, put in there y equals x, and press graph. Looking at the linear parent function, first off, it's always increasing. From left to right, it's going up. Then, it always goes through 0, 0. So, let me find my little lines here. I will start here. There we go. If you notice on the linear parent function, we start at 0, 0, and we're going up 1 and over 1, up 1 and over 1. It's always going up 1 and over 1. Okay? So this, you have to have this memorized. Now, this says, draw an example of a linear function. How do you know when something is linear? When it is in a straight line, because remember right here it says line. Now, that can be many different things. This is a linear function. This is the linear parent function. But if you wanted a different type, we could do any one as long as it was a straight line. That makes a linear function. The question is about two lines on a graph. No, I was giving you two different examples of linear functions. Linear functions just have to be a straight line. It doesn't have to be two of them. That's not, it's just I was giving different examples. So let me get rid of this one. The question 2, you talking about when they ask for a linear function, is there going to be two lines? No, when it's a linear function, they're just going to have an example of one. Okay, I was just using the same graph to show two different ones. Okay, so any linear function is just a straight line. Linear versus nonlinear. Oh, I didn't know it had all this. Okay, here we go. Linear. Let's remember, linear is a straight line. It has an exponent of 1. What that means is, like when we have y equals x plus 2. See how it's just the exponent, or I mean not the exponent, just the x? If it's just the x, there's actually an exponent. It just has a 1 up there. Okay, but they don't ever write that 1. Just like 2 is 2 to the first power, but we don't write that 1 up there. We just write y equals x plus 2. Has no roots with the x value. So no square roots. Okay, it does not have a square root. It does not have x in the denominator, like 2 divided by x. It has a constant rate of change between all ordered pairs. If it's nonlinear, nonlinear is anything that is not a straight line. It has exponents other than 1. So, for example, they have y equals x squared, x to the third. It'll have an exponent. It has roots with the x value, the square root of x. It may have x in the denominator or a fraction. So this cannot happen if it's linear, but that is what's happening when it's nonlinear. And the last little piece right here, it says the rate of change is different from one ordered pair to the next. So when we look at a table, the rate of change is different. Let me pause for a second. Okay, so let's look at this problem. It says Jocelyn was paid the following for wages for babysitting. What is the independent variable and what is the dependent variable? Okay, let's remember something first. Remember, independent is the x, dependent is the y. Independent is the thing that happens first. Dependent is the thing that happens second. What has to happen first? Do you have to work the number of hours or do you get paid first? You have to work those hours first. So the independent variable is number of hours. The dependent is the total fee. Now it says, do you see a linear relationship? Now it's in a table. I like to turn mine this way because it's easier for, whoa, nice line. 1, 2, 3, 4, 8, 16, 25, 34. How do you know in a table if it's linear? Delta y over delta x has to be the same. These go up by 8. What does this one go up by? 9. And the next one? 9. Nice handwriting, Crawford. All right, delta x. 1, 1, and 1. 8 over 1 is 8. 9 divided by 1 is 9. Is it the same the whole way down? No, this is not linear. And the reason why I know is because the rate of change is not the same. Rate of change is not the same. Or you can say, wait, hold on, is not the same. Or you can say delta y over delta x is not the same. Let's look at another example. This one says the cost of renting a DVD at a certain store is described by the function f of x equals 4x, in which f of x is the cost and x is the time in days. We are not considering tax in this situation. Would this be linear? So you're looking at this equation right here. F of x is the same as y equals. So we have y equals 4x. Looking at that right there, is that linear? If you don't know, put it in your calculator, put 4x in there and press graph. But it sure is because the exponent is a 1 and it's going up at the same rate of change. So, yes, it is linear. It has a consistent rate of change. It has a constant rate of change. Or you could say, if this was your test question, you could say you put it in the calculator and it made a straight line. Now, is this situation continuous or discrete? Thinking about this, continuous, remember when we graphed this, this is continuous is dots. I'm sorry, did I just say that? Discrete is dots. Continuous is a line. Discrete has to be certain numbers of things. Continuous can be 0.999999 or half of something. Can we walk into this store? It says that each CD is $4. Can I go in and say I want half of the CD because I only have $2? No, this has to be discrete. Why? Because you can't buy half of a CD. Now it says blank is a function of blank. Okay, I need you to remember that function of is the same as depends on. So y depends on x, or you could say that the dependent depends on the independent. Well, up here, what we're talking about is the cost and the time in days. What time in days? Oh, yeah, renting the number of DVDs. You know what? I went back. I should go this. I guess I was misreading this right here. But you can't buy half of it. It's not a CD. It was a DVD. Okay, you can't rent just half of the DVD by saying that I haven't seen the end, so let me just pay $2 to watch the last part, right? Try doing that at Blockbuster. Okay, so right here, your total cost depends on the number of DVDs rented. Now, down here, it says is if Lupe has $12 to spend, what is the maximum number of days she can rent a single DVD? Remember, the DVDs are the X's and the cost is the Y. I'm looking to see where the Y is 12, where it can be $12. Now, if I did this by hand, okay, my equation is Y equals 4X. This is my Y. I would make it 12 equals 4X. Let me move this up. What do I do to solve for X right here? Divide by what? I divide by 4, and I get X equals 3. So it would be 3 DVDs. I can also look it up in the calculator by going into Y equals, maybe, oh golly gee willikers, hold on. Go to Y equals, yeah, delete that. There we go. Put in there 4X and press second graph. I'm going to look and see where Y is 12. And there it is. And it has 3. I can find my answer there as well. Let's look at this next one. It says Mary was researching the fish population at her favorite fishing hole. She discovered that in July there were 4 fish. In August there were 16 fish. And for the month of September there was 256 fish. Does this represent a linear situation? Now, you'd have to go through the first thing I would do is build a table. And hint, you're going to have stuff like this. Oh, I didn't want the big red ones. All right. You're going to have to be able to do this from a word problem. This is one of your standards. So I have the number of, not the first thing would be the months. And after the months, we have the number of fish. In month 1, how many fish did we have? 4. In month 2, how many fish did we have? 16. The third month that they paid attention, how many fish? 256. Okay, wait. Now, hopefully you see that already. The change in Y plus 12 plus 240, right? Delta Y. Delta X, what am I going up by? 1s. I have 12 over 1 is 12. 240 over 1 is 240. Are they the same? No, this is nonlinear. Okay, and the way we know is because delta Y over delta X is not the same. Whoop, I hit the wrong button. The next one, it says, what is the domain of this set? Okay, first off, is this data continuous or discrete? Think about my 2 things. Either one of those 2 things, can I have half of them? What's the Y? The number of fish. Last I checked, I'm not going to go out and catch 2/3 of a fish. And if you do you want to keep it and eat it? Last I checked, no. Okay? Yes. Domain is X, yes. And Y is range, yes. Domain in this case is the number of months. Okay? But because the fish, we're not going to go out and throw a fishing pole to catch a half of a fish because we're not that hungry. Okay? It doesn't work like that. So my domain, the data is going to be discrete. So when I put domain, I'm going to do my set notation. And with what I have up here, I have 1, 2, and 3. I could go on to a reasonable number because you could keep catching or keep going and counting the months. But right now we're just using what we have. The range, remember, is the Y. And the range, use set notation. We started with 4, 16, and 256. You have to write it like this when it is discrete. And you need to remember what type of things are discrete and what are continuous. Let's check on this one. It says Auto Check Motors charged Paula $84 for an auto part plus $68 an hour that the mechanic worked to install the part. Now it's asking us if this is a linear equation. Let's think about the two things it's talking about. Let me see here. Let me get my lines. All right. If I get one auto part, how much is it going to cost me? 84 plus what though? Plus the 68. Okay? Now, I guess I should say it. What are the two things we're talking about? I know that it's total cost, right? Guys, when you have total cost, that's always going to be your dependent because that's your end result. Yeah, and so at first I was going through the auto parts, but they're not charging me for, we're only getting one part, right? What are they charging me for? The number of hours, because it depends on how hard it is to put that part in. Okay? So my X is my number of hours. So when my equation Y equals, I have to pay the 84 for the part, plus I have to pay $68 per hour. X is the number of hours. So at first for 1 hour, what is that? 141.52. Y'all going to help me or what? 84 plus 68. What about 2? So if I have 68 times 2 plus 84. 220. Because what am I going up by? What should I be increasing by each time? I should be increasing each time by 68. So the next one should be 288. If I'm always increasing by the same amount, is it linear? Yes. Yes, it is linear because I'm increasing by the same amount every time. So now it's asking me, the question was, is it continuous? Just a second, I'm going to get there. It says, write an equation to represent the total cost C of the auto repair that's required H hours of labor. Woo. All right, so my total cost C equals 84 plus 68H, which is the same as what I wrote up here. I just used different letters. Now, the question was, is it continuous or discrete? On the number of hours, I'm having to pay for each hour, right? But when you get an auto bill, can they bill you for 1.5 hours? Yeah, they can, right? On auto repair stuff, when you're talking about time, in this case, in any of those cases, when you go to the auto repair shop, they'll bill you for 0.25 of an hour, 0.5 of an hour, depending on how long that labor took. Normally, they don't do 0.99999 of an hour, okay? But really, a lot of times you can have parts of an hour. So in this case, it would be continuous. I mean, if they really wanted to bill you for 0.999 of an hour, they could. Okay, it just depends on their billing system. This one could have, I mean, you could have a discussion on this. It just depends on the place. The last piece on here, I think, is last. Oh, two more things. Blank is a function of blank. Remember that we have depends on. Y depends on X. What did we say the Y was up here? The total cost. So I'm going to have total cost is a function of the number of hours. The last one we have down here says, it cost Paula $560 to fix her car. How long did it take the mechanic to fix it? Okay, so in a table, 560 goes in the Y column, okay? First off, to solve this by hand, what was my equation? It was Y equals 84 plus 68x, right? To solve this by hand, you would take 560 and put it in here for Y. So 560 equals 84 plus 68x. So we can go and solve this by subtracting 84 from each side. Help me out here. What's 560 minus 84? 476 equals, these cancel. I get 68x. From here, there we go. From here, I would divide by 68. Again, why we need to know how to solve equations. So what is 476 divided by 68? I bet it's a fraction. Oh, it's an easy 7? Okay. So here, this would mean 7 hours. Now, we can solve it in the calculator by going in here, going into Y equals. Going into Y equals and putting in there 84 plus 68x and pressing second graph and going to look and see where Y was 560. And there's where I see the 7. Oh. The question was, how did I do it again? I went to Y equals, maybe. There we go. Went to Y equals, put the equation into Y1, 84 plus 68x, went second graph, and I went to go look in the Y column where it said 560 because that's how much it cost me. And 7 would be my answer. Okay, the last one. Right here it talks about Juan is going to rent a surfboard for the next 12 days. The rental rates are shown in the table below, including the basic fee. Okay, so we've got a basic fee for insurance plus a daily rate. It says write an equation that represents the total fee T in terms of the number of days in. One of the ways you can go through and find your equation right here when it gives you your data, we should know to go and build a table, but you know what? I need to turn it the other way. So let me see here. Let me flip to the other page. They didn't give me a whole lot of room. Building my table. Okay, so I have 1 and 25 and 2 and 40. 1 and 25, 2 and 40, 3 and 55, 4 and 70. 3 and 55, 4 and 70, 5 and 85, 5 and 85, and 6 and 100. Okay, so first thing you would do is find delta y, the change in y. What is it increasing by? 15. Each time it's increasing by 15. Delta x, the change in x, is increasing by 1. So now, remember, this is that table building from last year. Delta y over delta x, 15 over 1 is 15. That is my coefficient. Your coefficient, or delta y over delta x, goes here first. 15, 15, 15. Then you take it times your x. Remember, this is your x and your y. So I take it times 1, 2, 3, 4, 5, and 6. Okay, you multiply these two together. 15 times 1 is 15. You're trying to figure out what you need to add or subtract to get your y number, because you're trying to find your constant. 15 times 1 is 15. What do you have to add to 15 to get to 25? Plus 10. Your constant is the same all the way down. I think my equation is y equals 15x plus 10. You can double check that by going into the calculator and putting into y equals. Okay, really? Something with the little tablet here. Yeah, delete it. Okay, y equals, and putting in there 15x plus 10. Now when you go second graph, you should be able to look and see, do you have those points in there? 1 and 25, yes. 2 and 40, yes. 3 and 55, 4 and 70. All these numbers are there. So that means that I'm right. So now as I go back here and I go to try and write it, I have the total fee equals 15x plus 10. Now, oh, not x. What did it want me to use? N. 15n plus 10. Well, it'd be the same as writing y equals 15x plus 10. They mean the same thing. Now it says, what is the constant in the problem? The constant is what's not with the x. That's that 10, that $10. The two things that it talks up here is a basic insurance fee and a daily rate. A daily rate is what you pay each day. The basic fee for insurance is a one-time fee. Your one-time fee is your constant. So this would be your basic, insurance, basic fee for insurance. The coefficient is the $15. That's your daily rate. That's how much you're paying each day to rent it. So then it says, how much will Juan have to pay to rent the surfboard for 12 days? Well, number of days is the X. So it's for 12 days. I can look in the calculator there, or I can go to my equation. Y equals 15x plus 10. Did I do that right? Is that the equation? I think so. Yep. And so for 12 days, y equals 15 times 12 plus 10 if I did it by hand. To find out what y is, oh, off the top of my head, I don't know 15 times 12. So, and my silly board. Try again. All right. 15 times 12 is 180. So I'm going to have y equals 180 plus 10, which is y equals 190. So it's going to cost me $190. Now, I can do that by hand, or I can look in the calculator and go to y equals. There goes that. I got to remember to change that button on my pad. All right. So if I go in here and put in there 15x plus 10 and press second graph, I'm going to go and look and see where x is 12. And that's where I see 190. You can find your answer in the calculator as well.